Hey, welcome to Awesome Linux TV. If you've ever written an iptables rule and wondered where it actually fits in a packet's journey, this is the video for it. We'll walk through every chain a packet hits, what each table does, and by the end, you'll be able to reason about any firewall rule from scratch. iptables is the kernel's packet filtering system. It's been around since the early 2000s, and it's still the default on most Linux distributions. The idea is straightforward. Every network packet that enters, leaves, or passes through your machine hits a series of checkpoints. At each checkpoint, iptables walks through a list of rules to decide what to do, let it through, drop it, rewrite it, or hand it off for more processing. Tables are the top level containers, and they're checked in a fixed order: raw, mangle, nat, then filter. The filter table is the one you'll use most. It's where you decide whether packets live or die. NAT handles address translation, like when your machine acts as a gateway for a private network. Mangle tweaks packet headers for things like changing TTL or setting COAS marks. Raw exists to let certain packets bypass the connection tracking system entirely, which matters for high throughput setups. Here's the path a packet takes. It enters the kernel through a network interface, and the first chain it meets is prerouting. That's where raw, mangle, and the prerouting part of NAT run. After that, the kernel does a route lookup to decide if this packet is destined for a local process or needs to be forwarded to another host. If it's local, it goes through the input chain. That's where most of your firewall rules live. If it's being forwarded, it hits forward instead. When a local process generates a reply, that reply goes through the RGP chain and then onto post routing. Forwarded packets also pass through post routing on their way out. Every chain holds an ordered list of rules. Each rule has a match, like is this TCP on port 22, and a target that decides the packet's fate. The common targets are ACC pleat, which lets the packet through, drop, which silently discards it, and eject, which sends back an error message. The critical thing is iptables stops at the first matching rule, so order matters a lot. If nothing matches, the chain's default policy takes over. This script flushes the existing rules and builds a clean input chain. The first rule uses contract to allow packets belonging to connections already established. That's standard practice and it's fast. Then we explicitly allow SSH on port 22 plus HTTP and HTTPS. The default policy at the bottom drops everything else. Notice the order: establish traffic and these three ports pass through, and the rest silently hits the floor. Next time you're debugging a firewall issue, trace the packet through the chains and check whether your rule sits in the right spot. Thanks for watching Awesome Linux TV. Catch you in the next one. Bye-bye.